Welcome to another deep dive with us. Ready to tackle a concept that sounds a little intimidating at first.
Sounds fun. Hit me with it.
Okay, so it's the Central Limit Theorem.
Ah, a classic.
But trust me, once we break it down, it's one of those things that just makes you look at data differently.
Yeah, you start to see it everywhere.
Exactly. And to help us really visualize this, we've got this awesome interactive simulation from Open Educational Resources and Open Source Physics at Singapore.
I love when we can actually play around with these concepts. You know, it makes them less abstract.
Totally. So the Central Limit Theorem is all about what happens when you take a bunch of samples from a population and look at the distribution of their means.
Okay, let me see if I can explain this. So, imagine you're trying to figure out the average height of everyone, let's say, in your city.
Right. Good example.
You can't possibly measure everyone, so you take a sample, maybe 100 people.
Okay, makes sense.
You'd find the average height of that sample, but if you took another sample of 100 people, that average height would probably be a little different, right?
Yeah, probably. So how do we know how much we can trust any one of these averages?
That's where the central limit theorem comes in. If we kept taking more and more of these samples and we plotted all those average heights, on a chart, they start forming a specific shape.
Wait, a bell curve?
Bingo!
Yes.
A normal distribution. And the more samples we take, the closer and closer that distribution of our sample means gets to this perfect bell curve. That's the central limit theorem in action.
It's like the data starts behaving itself, right? Even if the individual data points are all over the place.
Precisely. And this is where it gets really cool. It doesn't actually matter what the original distribution of those heights looks like. So even if it's all wonky, those sample means will still, gravitate towards a normal distribution.
Okay, that's pretty amazing.
Yeah. And super powerful because it gives us a way to estimate those big overall population parameters, like the average height for everyone in the city with a certain level of confidence.
Gotcha. So in our simulation, we can actually see this happening, right?
Oh, yeah, absolutely.
We can mess around with the parameters like the mean and standard deviation.
And change the sample size, too. See what happens if we sample 10 people versus 100 people, or even 1,000.
So, we could set a scenario where the average height is 5'8" with a certain standard deviation, hit go on the simulation, and watch that bell curve emerge.
It's like magic, but it's math.
I'm starting to see why this is such a big deal. So just by looking at a bunch of these samples, we can get a decent idea of what that true average height for the whole city might be.
You got it. And there's always a but, right?
Uh-oh. What's the catch?
Sample size matters. Remember we talked about that ladder analogy?
You mean that thing about a stable ladder?
Yeah. A small standard error, which we get with those big sample sizes, that's like a nice sturdy ladder. You feel good climbing because you're less likely to fall. But if you have a large standard error from a small sample, that's like climbing a wobbly ladder. Not as confident.
So the fall in the data world would be like, what, making a bad decision because we only looked at a tiny sample?
You nailed it.
Okay, I'm liking this ladder thing. Big samples, more stable, more reliable. Makes sense. But how do we actually measure that wobbliness? Is that where this standard error thing comes in?
You are on a roll today. That is exactly where we need to go next.
All right, so let's take a quick break, and then we'll dive into that whole standard error business. Okay, so we're back and ready to tackle this standard error thing.
It's all about measuring how much those sample means we talked about might bounce around, compared to that true average for the whole population.
Right, like how far off could our sample average be from the actual average for, say, everyone's height in the city?
You got it. And that standard error, it depends on a couple of things. One is how much variation there is in the original data. Are all those heights clustered close together, or are they spread out all over the place?
Okay, so if the original data is all over the map, our standard error, that ladder wobbliness, is going to be bigger, right?
Yeah.
More uncertainty.
You're getting it. But here's the really key part. The size of our sample, that has a huge impact on standard error.
So bigger sample size, smaller standard error, less wobbly ladder. Gotcha.
Bingo. And this is where it gets real. Imagine you read a headline about some study saying broccoli makes you run faster.
Okay, I'm intrigued.
But what if they only tested 10 people?
Yeah. That doesn't sound like a lot.
Right. The difference they found could just be random, a fluke.
So what you're saying is, thanks to our central limit theorem knowledge, I can look at that and say, hold on, that sample size is tiny. I'm not buying it.
Exactly. You're like a statistics superhero now.
I like the sound of that. So to recap, we've got this awesome simulation letting us see the central limit theorem in action. We can play with sample sizes and see how that standard error changes.
It all ties together, doesn't it?
Yeah, it's not just theoretical. It actually has real-world implications, like helps us evaluate studies and polls.
And it's everywhere, right? Whether we're talking about elections or a new health study, this stuff helps us figure out how much we should trust those claims.
So it's not about becoming a math genius. It's just about having the tools to ask the right questions.
Like, how big was that sample? How spread out was the data to begin with? Simple things that can make a huge difference.
Makes you a more critical consumer of information.
Couldn't have said it better myself.
This deep dive has been awesome. We've really broken down the central limit theorem and this whole standard error concept.
It's pretty cool how these ideas can help us understand so much about the world.
I feel like I've leveled up my stat skills for sure. But I'm curious, what are some other ways this central limit theorem impacts our daily lives? I bet there's more.
Oh, absolutely. Let's take another quick break, and then we'll get into some more of those real-life examples.
All right, we're back. You know what's really cool about this is how we can use this knowledge about the central limit theorem in our own lives. It's not just some abstract idea, it's actually helpful.
Absolutely. Like when you're reading those online reviews for, I don't know, a restaurant or a hotel or something.
Oh yeah, everyone looks at those.
Exactly. And, you see those star ratings, you're basically looking at a sample mean, averages based on other people's experiences.
Right. And if we only see like 3 reviews, we probably shouldn't put too much faith in that average.
It's that wobbly ladder all over again. But if you see a rating based on hundreds of reviews, that's a much sturdier ladder.
So it's not just about the number of stars, it's about how many data points went into that rating.
Precisely. The central limit theorem helps us be more critical, more informed, and it goes beyond those online reviews too. What about those times when someone tells you, oh, my friend tried this diet and they lost a ton of weight?
That's like a sample size of 1. Not very convincing, statistically speaking.
Exactly. So understanding this stuff helps us avoid those anecdotal traps.
We're less likely to jump to conclusions based on limited data. It's like we've got this new lens for looking at the world thanks to the central limit theorem.
I love that analogy. This is what it's all about.
Yeah. And that's why this deep dive has been so cool. We went from this kind of intimidating concept to actually understanding how it works, how we can visualize it, and how it shows up in our daily lives.
It's about connecting the dots between theory and reality, right?
Absolutely. And I hope it's given everyone listening a new appreciation for statistics. It's not just about formulas, it's about understanding patterns, making smarter decisions,
And being more confident in navigating this world that's just overflowing with data.
Well said. And with that, I think we've reached the end of our deep dive into the central limit theorem. We hope you enjoyed it.
Keep those ladders stable out there.
And we'll see you next time.